So let's find the exact value of the sine of 30 degrees. Now, it's understood, this is multiplication. This is, and it's understood that the input is 30 degrees. There's an implied set of parentheses here, 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 and here. So this is actually an expression with two terms. The terms are defined by the products. So the first term is the sine of 30 times the cosine of 45. Then we're told to subtract off the second term, tangent 60 times cosecant 45. And somehow we want to get the exact value of this. You could just plug and chug here. What's the sine of 30 degrees? That whole thing is, sine of 30 degrees is 1/2. Now, for whatever reason, some students get it in their head that the answer is the sine of 1/2. No, 1/2 is the output. The input is 30 degrees. The sine of 30 degrees is just 1/2. So you can replace that sine of 30 degrees with just 1/2. What about the cosine of 45? So this guy, this whole thing, cosine of 45, is root 2 over 2. So you can replace or substitute radical 2 over 2 in for cosine of 45 degrees. Tangent of 60. So what usually happens is students get in their head, oh, I know it's either root 3 over 3 or root 3, but I can't remember which one. Well, the tangent increases over time, or for bigger inputs, you get bigger outputs. So root 3 over 3 is smaller than root 3. And 60 degrees is bigger than 30 degrees. So one way, if you can just remember the numbers, you can remember, oh, it's got to be the bigger number that pops out. So it's got to be, the tangent of 60 has to be what? Just root 3. So that whole thing, and with the minus in front of it, is equal to root 3. So substitute root 3 in for tangent 60. Cosecant 45 is not as easy. Let's do a little scratch work here if you don't have it memorized. Cosecant is 1 over what? So the cosecant of 45 degrees is 1 over sine of 45 degrees because of the reciprocal relationship between cosecant and sine. And what's the sine of 45 degrees? So it's 1 over root 2 over 2. How do you rewrite, if you want to simplify that before you plug it in? 2 over root 2. And this is one case where it's definitely worthwhile to get rid of that radical in the denominator. What would you multiply by? Root 2 over root 2. What are you really multiplying by when you multiply by root 2 over root 2? 1. Okay, do you see why it's worth doing? You're going to get 2 times root 2 on top, but what do you get on the bottom? Root 2 times itself is 2, and what's going to happen to the factor of 2 on top and on bottom? Gone. So the cosecant of 45 degrees is just root 2. And yeah, you're expected to simplify it that much. And by the way, wouldn't it be the same for the secant of 45? Wouldn't they both be root 2? Because the sine and cosine of 45 are both root 2 over 2. So yeah, it's just root 2, and it's definitely worth doing that scratch work before you plug it in because it cleans it up quite a bit so that this guy right here is just root 2. So that's algebra you guys all know, but you're probably rusty at it, which is why I'm going into detail here. Okay? So don't just blow it off and think, oh, I know this stuff. You do. But if you don't practice it, you're going to be rusty at it, which is going to lead to mistakes at some point. So hopefully I don't irritate you too much by going into this much detail, but I do that because I like to err on the side of caution for the people who haven't had math in a while, or the people who are rusty at math. Now we're not done. We need to simplify. If you multiply this first product together, what do you get? Multiply straight across. 1 times root 2 on top is just root 2, and then 2 times 2 on the bottom is 4. Do you guys remember how to multiply radicals? It's root 6, remember? A lot of students forget this. Even at this level, I've taught this class many, many times, and also trig many, many times. And one very common mistake is just to leave it as root 3 times root 2. They forget how to multiply this stuff. You keep one big radical and multiply the radicands together. So it's one big root 3 times 2 is 6. So root 6. Like like that. Okay? And that's good enough. You could get a common denominator with, you can stop there, by the way. But if you wanted to get a common denominator here, multiply the root 6 by 4 over 4, and you could write it as one big fraction, which would be root 2 minus 4 times root 6 all over 4. But I don't think that really looks any better than the original way I wrote it with just the minus root 6 on the end. But you should be aware that you can do that, though. It comes up.